A massive stellar flare trillions of times more powerful than the brightest solar flare from our sun may have been caused when a star ripped apart and devoured a massive gas giant planet. New research could solve the mystery of why the infant protostar Fu Ori, located 1,200 light-years from Earth, significantly increased in brightness around 85 years ago and has still not dimmed to its expected luminosity. Astronomers have theorized that the increase in brightness of Fu Ori is the result of matter being fed from a disk of superhot gas and dust around the young star to its surface. A simulation created by a team at the University of Leicester suggested the extraordinarily energetic event was caused when a planet 10 times the size of Jupiter ventured too close to the growing star. This resulted in this super Jupiter undergoing what the team called an extreme evaporation, burning up in a superheated soup of material swirling around the star. Some of the remains of the planet were then fed to the star. We discovered a new process which you might call a disk inferno of young planets. University of Leicester School of Physics and Astronomy professor Sergei Nyakshin said in a statement. Nyakshin explained that as protoplanetary disks feed growing stars with material, they can also nurture infant planets. Protoplanetary disks are often called nurseries of planets. But we now find that these nurseries are not the quiet places that early solar system researchers imagined them to be, he said. They are instead tremendously violent and chaotic places where many, perhaps even most, young planets get burned and literally eaten by their stars. In the simulation, Nyakshin and the team modeled a gas giant planet as having formed far out from Fu Ori when gravitational instabilities in the protoplanetary disk caused fragments of matter to create clumps larger than Jupiter, but much less dense than the solar system gas giant. These clumps, or planetary seeds, were quickly drawn in closer to the protostar. Things really heated up when the clumps, now conglomerated into an infant planet, reached a distance equivalent to around 9.3 million miles, 15 million kilometers from the star, about a tenth of the distance between Earth and the Sun. Here, the material in the disk of gas, hot gas, and dust, known as a protoplanetary disk, is so hot that the outer layers of the planet's atmosphere ignite. During the simulation, these atmospheric layers were stripped away and became part of the superhot gaseous soup that makes up the protoplanetary disk. The super Jupiter is so close to its star that the gravitational influence of Fu Ori generates extreme tidal forces within it, stretching the planet in one direction and squeezing it in the other in a process called spaghettification, which rips it apart. This provides the star at the heart of the protoplanetary disk with a massive reservoir of fresh material to feast on, growing its mass and causing it to brighten significantly, causing the powerful flare. This was the first star that was observed to undergo this kind of flare, team member and University of Leicester scientist Vardan Elbakian explained. We now have a couple of dozen examples of such flares from other young stars forming in our corner of the galaxy. Elbakian added that while the Fu Ori flaring is extreme compared to normal young stars in terms of both duration and observability, the team thinks that most developing planetary systems may flare up in a similar way dozens of times or more while their protoplanetary disk is still present. If our model is correct, then it may have profound implications for our understanding of both star and planet formation, Nyakshin concluded. It is now important to understand whether other flaring stars can indeed be explained with the same scenario.